So here is our Quartus Prime project. This is the files we used. Then we take the three MOOCs files, okay, 2, 4, and 8, and then we created an intcomp 16-bit BHD file. What we did is we used two comp 8 bit. The first one reads the most significant bits, the 8 most significant bits, and then that's the high comp, and then the other one, in case that the first one the output is equal, is going to see what's the final output. Okay, so now we are going to run the project. We have to wait a little bit. So as you can see, we have 0 errors in our project, in the code. So right now we are going to see the RTL viewer. Okay, here we have it. As I was explaining before, we have two components. The first comp is the high comp, that takes the most significant bits, the 8 most significant bits from the input A and B. Then we have, as you can see in AI, you have there an H1. That means that we the first time we put they are equal. We suppose that they are equal numbers. Then we can see the three outputs equal, greater than, and less than. And then we have the other comp, that comp 8 bits low comp, that in case that the first component, the 8 most significant bits are the same, we will see which is going to be the output, or we will determine which will be the output with the second component. That does the same, but instead of the most significant bits, it does the same with the less significant bits. So now we can see how the components work inside. Okay, both components are the same. And now we are going to see here, clicking on netlist viewers and then clicking to technology map viewer post fitting, we will see another schema. Okay, here we can see the two components plus all their buffers. As we can see here, if we click there, we can see this. Okay, and the other one is the same. So once we saw all of this, right now we are going to create the test bench. So we are going to go to start. Okay, start, and then start test bench template writer. So we are going to create the test bench file that we will use later on the multisim.
Hello, I'm Ivan Franco from group 53, and I'm going to introduce you to ModelSim in order to get right the intcomp 16-bit. So let's get started. So we open ModelSim and we have created a new project in CSD P3, the name of the chip, and the project name is the chip name and underscore model sim. So we only have to go to file, load, so we have to do is right click on the blank, add to project existing file, let's click browse, and let's go to our PLA3 folder, and we select the testbench file that my colleague did in the past video, the UACPL of the comp of this 16 bits and comparator of 8 bits. Let's open, click OK, and then we have to click on here to compile all the files in order to check there is no errors or syntax mistakes on the UBACDL files. So we click it, and as you can see we have 3 files compiled and 0 failed with no errors, so it's okay. In order to start the simulation, we go to the menu and click on simulate and start simulation. We go all down to work functional, that is our library name, and click on the comparator on we see that the file have underscore tst, so we click on it and click OK. So this is the model sim and this is our chip, so we are going to click it, right click, add to wave, all times in region, and it will pop up this this window. This is the way that we have to fool with our inputs and outputs. So we have add new divider, input divider have, let's put it 30, and another divider name output, and 30 divider height as well. So we move A input and B input, and greater than, equal, and less than output right here. So for the inputs we just right click them and radix and decimal, so we can see the binary number to decimal, so we can understand it better. So same thing from input B, let's put in decimal, and then let's back to model sim, and in this transcript page that we have, we run this, we run the project, run, we can say 300 US, so we run it, and then we click the key O to zoom out this so we can see it better. Okay, so here we have it. When A is 0 and B is 0, they are equal, so the equal is going to be 1 and the other ones are 0. When A is minus 31,000 and B is plus 22,000, so A is less than B, so less than is with a 1 and the other ones are 0. In the third case we have that A is minus 1900 and B is minus 3000, so we can say that A is greater than B, so GT is going to be 1 and the other ones are going to be 0. And for case 3 we have that A and B are the same number, so equal are going to be 1 and the other ones are going to be 0. We can run it for 100 seconds. Alright, and then we have the fourth case, when A is minus 5,000 and B is plus 15,000. So we have that B is greater than A, or otherwise, other way to say it is A is less than B. So we have here a 1 on less than and 0 or greater and equal value. So we can see if I move this column, the values are changing in function that we are seeing. When we have seen this, we can close the tab, and in order to end the simulation, we go to menu simulate and end simulation. We click on yes, and once I went here, we go to project and see the status are okay, so we can quit the program with any issues. I hope you like this video, and see you in the next.